Hi, my name is Carlos Andres Hernández Sepúlveda. I am a civil engineer student at the Agrarian University, and today I will make a summary on structural analysis. To begin, structural analysis is the determination of the effects of loads on physical structures and their components. Structures subject to this type of analysis include all those that must support loads, such as buildings, bridges, airplanes, and ships. Structural analysis use the fields on applied mechanics, material science, and applied mathematics to calculate the deformations of a structure, internal force, stresses, support reactions, accelerations, and stability. Structural analysis is a key part of structural engineering design. Structures and loads. A structure refers to a body or system of connected parts that are used to support a load. Important examples related to civil engineering include buildings, bridges, and towers, and in other branches of engineering, ships and airplane frames. Tanks, pressure vessels, mechanical systems, and electrical support structures are important. Classification of structures. A structural system is the combination of structural elements and their materials. It is important that a structural engineer be able to classify a structure, be its shape or its function, recognizing the various elements that make up that structure. The structural elements that give the systemic force through the materials are not only a connected rod, a truss, a beam or column, but also a cable, an arch, a cavity or channel, and even an angle, a surface, structure or frame. Loads. Structural design begins with specifying the loads that act on the structure. The design law for a structure is often specified in building codes. There are two types of codes: general building codes and design codes. Engineers must meet all code requirements for the structure to remain reliable. There are two types of loads that a structural engineer must find in the design. The first type of loads are dead loads, consisting of the weights of the various structural members and the weights of any object that is permanently attached to the structure. For example, columns, beams, the floor slab, ceilings, walls, windows, plumbing, electrical accessories, and other miscellaneous accessories. The second type of charge are live chairs that vary in magnitude and location. There are many different types of live loads such as construction loads, highway bridge loads, railway bridge loads, shock loads, wind loads, snow loads, earthquake loads, and other natural loads. Analytical methods. To perform an acquired analysis, a structural engineer must determine information such as structural loads, geometry, support conditions, and material properties. The results of such analysis usually include support reactions, stresses, and displacements. This information is then compared to criteria that indicate fault conditions. Limitations. Each method has notable limitations. The materials mechanics method is limited to very simple structural elements under relatively simple loading conditions. However, the structural elements and the permitted loading conditions are sufficient to solve many useful engineering problems. The theory of elasticity allows the solution of structural elements of general geometry under general loads conditions. In principle, The analytical solution, however, is limited to relatively simple case. Solving elasticity problems also requires the solution of a system of partial different equations, which is much more mathematically demanding than solving material mechanics problems, which require at most the solution of an ordinary differential equation. Methods of resistance of materials, or classical methods. The simplest of the three methods discussed here, the materials mechanics method, is available for simple structured elements, subject to specific loads such as axially loaded bars, prismatic beams in a state of poor bending, and circular shafts subject to torsion. For wall system analysis, this approach can be used in conjunction with statics, resulting in the sectional method and joint method for truth analysis, moment distribution method for small rigid frames, and portal frame and cantilever method for large frames. Sections method. This method can use it when the force of the lattice elements of only a few members are to be found. Elasticity methods. Stretch methods are generally available for an elastic solid of any shape. Individual elements such as beams, columns, axes, plates, and shells can be modeled. The solutions are derived from the linear elasticity equations. Methods that use numerical approximation. It is common practice to use approximate solutions of differential equations as the basis for structural analysis. This is generally done using numerical approximation techniques. The most widely used numerical approximation in structural analysis is the finite element method. Okay, thanks for watching the video. Bye.